Good morning, this is the advice video for assignment 8. I'm going to show you how to use the simulation and give you a couple of suggestions for answering questions 7 through 10. If you aren't already on Concord Activity 4, Question 7, navigate there now. When you're looking at the simulation, the first thing you want to do is to notice how dragging the pendulum changes its height and also changes the amount of potential energy that the pendulum has. If the pendulum is lower, it has less potential energy. If it's higher, it has more potential energy. Potential energy can be defined as the amount of energy that is stored in an object, usually due to its relative position. If it's higher, it has more energy. If it's lower, it has less energy. I'm going to click Start, and then I'm going to pause the simulation almost immediately. You'll notice as it swings down, the amount of potential energy decreases as it reaches the bottom of its swing, but the amount of kinetic energy increases. You can see this in the graph at right. The green line shows potential energy decreasing, and then increasing again as the pendulum swings up. The purple line shows the amount of kinetic energy increasing, then decreasing as it slows down to turn. Thermal energy is the orange line. Thermal energy is heat being transferred from the pendulum to its surroundings as it swings. If we let this simulation play until the pendulum stops swinging, you'll notice a few things. One is that potential energy and kinetic energy alternate. When one is high, the other one is low. The other thing you'll notice is that the amount of thermal energy continues to increase, while the amount of potential and kinetic energy overall decrease. However, the gray line, showing total energy, stays the same. Let's look at the questions. Question 7 asks you to identify two examples of energy changing from one form to another. Listed in the box below are a couple of suggestions for how to start with your first example, noticing before the pendulum is released all the energy is in what form, and then as it swings, as it begins to move, what form does that energy change into? The second example is up to you. Question 8 talks about what object has energy. One place to start would be to notice at the beginning, the only type of energy you could see was potential energy. What contained all the potential energy, and where did that energy go? As the potential energy decreases, thermal energy increases. The thermal energy is the heat of both the pendulum and the air around it. Remember, air is an object even though you can't see it. Question 9 talks about total energy, when the pendulum starts at 0 seconds and when the pendulum stops. Although it goes behind the legend, you can see the gray line showing total energy stays the same throughout the simulation. Finally, question 10 asks you to use evidence from the pendulum demonstration in the last lesson and in this simulation to explain what happens to the pendulum's kinetic energy as the pendulum comes to a stop. Remember, kinetic energy is shown as the purple line on the graph. As it swings faster, it has more kinetic energy. Each time it reaches the top of an arc and turns around, it actually stops for a second and has less kinetic energy. However, over time, the amount of kinetic energy decreases and the pendulum stops moving. What form of energy increases? The hint is that the kinetic energy is being turned into a different form of energy. In this case, we see near the end all we have left is thermal energy. Think about that as you're answering the question. What is around the pendulum? What is it that could be increasing thermal energy or heating up as the pendulum swings? If you have a question, leave a private comment or come to a class meeting and I'll try to clear it up. Good luck!